In this video, we are going to learn about polynomials. First of all, let us consider what a term is. Now, a term is a number, a variable, or a product of numbers and one or more variables raised to exponents. Let us consider a few examples. 3 is a term. This is because it is a number. Y is also a term. This is because it is a variable. Another term is 4x to the power of 2. This is because it is the product of a number and a variable raised to an exponent. Another term is negative 10 times ABC. Now here, note that we can write a as a to the power of 1. We can write b as b to the power of 1. And we can also write c as c to the power of 1. So this is the product of a number and 3 variables raised to exponents. So this is an example of a term. Another example of a term will be 7 times the square root of x. Here we have the product of a number and a variable raised to an exponent. Now, square root over x is indeed a variable raised to an exponent because we can write the square root of x as x to the power of half. So 7 times root over x is also a term. Let us consider another example. We have 64 divided by x to the power of 3. Now note that we can write 64 divided by x cubed as 64 times x to the power of negative 3. So once again, we have the product of a number and a variable raised to an exponent. So 64 divided by x cubed is also an example of a term. Next, let us consider what we mean by an algebraic expression. Now, an algebraic expression is a term or a sum of 2 or more terms. Let us consider a few examples. Now, 5x is an example of an algebraic expression because it is a term. Let us consider another example. We have 40x cubed plus 99 times square root of x. Now this is a sum of 2 terms. This is the first term, this is the second term, and we have the sum of these 2 terms. So 40x cubed plus 99 times the square root of x is an example of an algebraic expression. Another example is 2y minus 4. Now note that we have subtraction over here, but we can write this as the sum of 2 terms. We can write this as 2y plus negative 4. So the 2 terms are 2y and negative 4, and this is the sum of these 2 terms. So 2y minus 4 is another example of an algebraic expression. Let us consider another example. If we consider the expression x plus x to the power of 4 minus y, this is also an algebraic expression. In this case, we have 3 terms. Next, let us consider what we mean by a polynomial. Now, a polynomial is an algebraic expression which consists of a term or a finite sum of terms of the form a times x to the power of n. Here, a is any real number, x is a variable, and n is a whole number. We call this real number a the coefficient of x to the power of n, and we call the whole number n the degree of the term. Now let us consider a few examples. Consider 5 times x to the power of 3. Now this is a term of the form a times x to the power of n. Because of that, 5 times x to the power of 3 is a polynomial. Let us consider another example. Let us consider 3t squared plus 4t minus 7. Now, note that we can write t as t to the power of 1. And for the constant, we have negative 7. We can write that as negative 7 times t to the power of 0 because t to the power of 0 will be equal to 1 using the zero exponent law. And negative 7 times 1 is just negative 7. So if we have a look at the first term, it's of the form a times a variable to the power of a whole number. Similarly, for the next term, we have a real number times a variable raised to the power of a whole number. For the next one as well, we have a real number times a variable raised to the power of a whole number. So 3t squared plus 4t minus 7, this will be another example of a polynomial. Let us consider another example. Let us consider negative y cubed plus y squared minus y plus 1. We can see that the variable in this case is y, and all of the exponents are whole numbers. For example, over here we have y. We can write that as y to the power of 1. And for the last term, the constant, we can write that as 1 times y to the power of 0. So all of the variables are raised to whole number exponents. So negative y cubed plus y squared minus y plus 1, this is another example of a polynomial. Let us consider another example. ab squared plus 62b cubed plus a squared c. This is also an example of a polynomial. We can write the first term as 1 times a to the power of 1 times b to the power of 2. The next term we leave as it is, and the last term we can write as 1 times a squared times c to the power of 1. So we can see that each term is the product of a real number and variables raised to whole number exponents. So ab squared plus 62b cubed plus a squared c is also an example of a polynomial. Now note that in the first example, the only variable is x. So we call 5x cubed a polynomial in x. The next example has only one variable, which is t. So we call 3t squared plus 4t minus 7 a polynomial in t. For the next one, the only variable is y. So we call this a polynomial in y. And in the last one, we have three variables. We have the variable a, we also have the variable b, and we also have the variable c. So we call ab squared plus 62b cubed plus a squared c a polynomial in a, b, and c. Now let us consider a few practice problems. Let us determine whether the given algebraic expressions are polynomials or not. Now let us consider this first one. We have x to the power of negative 3. Now the exponent is negative 3, and that is not a whole number. So we have a variable raised to the power of a number which is not a whole number, and because of that, this is not a polynomial. So no, this is not a polynomial. Now let us consider the next one. We have 1 divided by y. Using the negative exponent law, this is equal to y to the power of negative 1. So we have a variable y raised to the power of a negative number, which is not a whole number. And since this is a variable raised to the power of a number which is not a whole number, the answer for this one will be no, this is not a polynomial. Let us consider the next one. We have t to the power of 3 plus t to the power of 8. So we have two terms, t to the power of 3 and t to the power of 8. And in both cases, we have a variable t raised to the power of a whole number. This is because 3 is a whole number and 8 is also a whole number. So the answer for this one will be yes, this is a polynomial. Now let us consider the next one. We have the square root of 9 times x. So we can split this. Now this can be written as the square root of 9 times the square root of x. And the square root of 9 is equal to 3. So we have 3 times the square root of x. And the square root of x is equal to x to the power of half. So we end up with a number multiplied with a variable raised to the power of a fraction. That is not a whole number. And since the variable is raised to the power of a number which is not a whole number, Because of that, the answer for this one will be no. This is not a polynomial. Let us consider the next one. We have the square root of 9 times x. Now the square root of 9 is equal to 3, and we have x. So we have 3 times x, and we can write x as x to the power of 1, so that we have the product of a number and a variable raised to the power of a whole exponent. Because of this, we can say that this is a polynomial. So yes, this is a polynomial. Let us consider the next one. We have the square root of 9 plus x. So we can see that the variable x is under the radical symbol. So we cannot write this algebraic expression in the form of the sum of terms of the form ax to the power of n. And because of that, the answer for this one will be no. This is not a polynomial. Thanks for watching this video. I hope you enjoyed it. Don't forget to comment, like, and subscribe. See you next time.